Welcome to this session, and we're still using Matlab as a calculator. Okay, our scientific calculators today are very developed. You can testify, I'm sure. It has more functions than mere addition, multiplication, exponent, and all what we've seen so far. Right? Our scientific calculators today are able to calculate the exponential of a particular number. They are able to calculate the logarithm to the base 10 of a particular number. They are able to calculate the sine, the cosine, the tangent, etc. of different numbers, right? Matlab is no different. By the way, Matlab is way more powerful than that. So we will take advantage of this opportunity to present the documentation of Matlab. The good thing about the Matlab software is that it comes with everything you need to know in order to be efficient in the software itself. The help documentation of Matlab is very well organized and very well detailed, right? For your utmost use. So to go there, you either click on this question mark or you click here. Okay, I love this one. Well, I love this one. I love, choose any one, right? Or you press F1 and it leads you straight to the documentation. Okay, and in the documentation I will get Matlab, and in Matlab I will take mathematics, and here I will take elementary maths, right? So this is a list of possible functions that Matlab have. These are built-in functions. Built-in functions mean that it comes with the Matlab package just for you to use. They are functions that have been described by MathWorks themselves, and it just comes for you to just execute and use at will. Okay, so the functions are categorized. You have trigonometric functions, you have exponents and logarithms, you have complex numbers, you have discrete maths, polynomials, special functions, Cartesian coordinate system. In fact, they are in all sorts of orders. But for an introduction, right, we will focus on just seeing some of them so that we understand, take advantage and understand how Matlab understands functions. Okay, so if we go to trigonometry, okay, for example, what will you see? You will see this is the sine function, and it is very well explained. Sine of argument in radians. So this sine will calculate the sine of a particular angle given in radian. Sine d in another function will calculate the sine of a particular angle given in degrees. So let's stop at the sine for a bit and go and understand how to execute this in Matlab. Okay, so if I reduce this to go back to Matlab, here we are on the command window. So let's give ourselves signs of some angles that we know. What angle do you know? Sine of 0, for example, is 0, obviously, right? So if I say sine of 0, that should give me 0. Okay, sine of 30, remember, that should be half. Okay, but look at this. If I say sine of 30, look at the answer. Is that half? No, it's not half. But why is it not half? Because the 30 I have indicated is in what? Is in degrees. And by the way, that's simply the way you use these functions. Okay, it's as simple as you see it. You use sine, you open the bracket in order to put what we call the argument in. Okay, in order to put the data that is expected to be processed by the sine, and it will give you the corresponding result. So we have a problem here. Okay, so this is not indicated in radians, so this should allow us to introduce the concept of pi. Okay, so we remember in mathematics pi is equals to what? Pi in radians corresponds to 180 degrees, right? So the pi here is well defined. It's just pi as you say it. Okay, that is our function pi. It is a constant, a built-in constant into the Matlab environment. Look at how awesome Matlab can be. So again, if I say pi, it is already built in. Okay, so if I say sine of pi is 180, so it means 30 degrees will be what? Divided by 6, right? Exactly. It gives me our answer 0.5. Okay, so look at how this does. You can put an expression into the bracket and it will compute the expression first before executing the function. As beautiful as that. Okay, so let's use sine d now. So it will be sine d of, I can't use pi on 6 here because the answer expected here will be in degrees. And look at what I did here expressly. When you put sine d and you open just one bracket, here it gives you what is expected, okay? You will see that it expects just one variable x, and this x is supposed to be in degrees. So we'll put 30 and close, and it gives us the same 0.5, right? So let's go back to our help window because there are some things that I need to show you right there. Okay, here we are. So if you want to know how this function goes, you just click on it, okay? There is a whole documentation on that. So y is equals to sine x. Y is equals to sine x returns the sign of the elements of x. The sine function operates element wise on arrays. Arrays which we have not yet seen, which we are still to see, okay? The function accepts both real and complex inputs. For real values of x in the interval sine returns real value. It gives you details on how the function goes, okay? And if you click on example here, you can see some examples, okay? Very, very detailed documentation. Very detailed documentation. I have not seen better just yet, okay? So let me not say there's no better. Some people can hang on my neck for that. Good. So let's get back and see some more functions, right? So we've seen sine, so there's also a sine, there's a sine d, there's cos. All of these functions are here, okay? All of the trigonometric functions, you know, are present here. You just need to read your definition to make sure that you have the right one, okay? So that's that for trigonometric functions. If you want to do exponential and logarithmic function, this is the exponent, okay? So if I want to say e to the something, I just use this exponent. So let's go and try that out. So TLC. So if I say x and I open the bracket, pap, it gives me what we call the function prototype. It tells me one value here is expected, okay? And if you don't understand what this, you can still click on more help here, and what happens, it will give you that very description right here of what this exponential function does exactly for you. And it tells you the exponential function returns the exponential for each element of array x, okay? The function accepts both real, etc. You can read that for yourself, right? So why am I showing you this? Let me say of 4, for example. I am showing you this for you to understand that if you need to understand anything in Matlab, their help documentation is well organized, okay? All of the mathematical functions are there for you. You can just come here and browse through them, okay, and see the options that are available for you. One of the common things, you have the square root here, for example, okay? But at times you also want to compute the cubic root. You also want to compute and this is where the nth root function comes into play. Let's try and apply that, okay? So if I want the square root, give me those numbers. If I want the square root, I'm reading some of your minds now, of a particular number, it will be, for example, 4, okay? It gives me 2, okay? But let's say I want the cubic root of 8. We know 2 times 2 times 2 is 8, right? So I want the cubic root of 8. That's supposed to give me 2, okay? There, I will use the nth root function. And this is different, okay? Now you see that we have 2 arguments in. We have 2 values to indicate, and the 2 values that we indicate are always separated by commas, okay? So the first value, if we press more help here, we will know. So returns the real nth root. N here stands for the n here. So if you want the cubic root, it will be 3. If you want the 4th root, it will be that, etc. Right? Of the element of x. So the number we indicate is at this level here. So it means if I want the cubic root of 8, I have to say 8 comma 3, and that gives me 2. As simple as that, okay? So what have we learned today? We've learned that in the help documentation of Matlab, right, you have all of the functions well defined that you need in your mathematics way beyond your calculator, okay? And all you need to do is to use them the way they are defined, just the way they are defined. When you use this function and enter this value x, it will give you this answer y, okay? As simple as that. Good. So that closes this session. See you in the next lesson.